Good evening, everybody. I'm just creating a video demo over here on to explain how to use the tool Ben, which is a fault localization tool. To begin with, Ben is a fault localization tool which takes two input files. One of the input file is a source code file. The second input file is a file which consists of parameters, constraints, and initial test set information, which was generated from a tool called Axe. So to start the any project in Ben, just click on a new button over here and you can select an appropriate project name. In our example, what I am planning to do right now, for example, is use the replace program from the Siemens suite, and I'm going to use the 26th version of the replace program. So I give the project name as replace. I need to select the input file which I have in my desktop. As I told you, I'm using the version 26 of the replace program. So picking up the 26th version. Okay, here we go. This is the input file. This is, I need to select the source code file as well. The source code file is the same location, so sorry. This is my source code file, and I create the project. So when I create a project, it displays the basic information. The master file is nothing but a project information file which helps us to know what is the project name and where is this first source code file, as well as the initial test set file. The source code is a, when you click on source code window, you get to see the source code displayed over here. The input file consists of this information: parameters and its values, constraints, and initial test set with its results. So to begin using this tool, as you might know by now, Ben works in two phases: phase 1 and phase 2. And phase 1, we identify the failure inducing combination, and phase 2, which involves identifying the faulty statements. So to begin phase 1, you can either use run phase 1 run iteration, or use the button on the toolbar phase 1. So currently the application is still executing. I guess phase 1 is completed. Yes. So at the end of every iteration in phase 1, Ben generates a list of suspicious combinations and rank them based on their suspiciousness value. For this iteration 1, these two are combination of variables, I mean pat negate with a value of 2 and pat negate star with a value of 1, seem to be highly suspicious. And also Ben suggests a set of 10 test cases to be executed by the user. The main purpose, or the main idea behind requesting the user to run these test cases is like, at this point Ben is not the algorithm thinks executing these test cases and providing results for the suggested test cases will help the algorithm to further narrow down the inducing combination which is causing the failure. However, the user can decide not to run this and directly go ahead to phase 2. So in order to go to phase 2 without executing these test cases, you can directly go over here to inducing combination, select a value, and follow the procedure from there on. But in our case, I have decided to execute these recommended test cases. So I have already executed them and I have the results ready with them. In case if you're using the tool for the first time, you might need to provide the you might need to execute these test cases and provide the results for these test cases. Based on my test execution, I'm updating the test results for iteration 1, test number 5, and test case number 10 resulted in a failure. Rest everything is in a success state. So I update these test results and continue with phase 2. Sorry, iteration 2. So again in iteration 2, based on the results we provided over here, Ben identifies the latest suspicious combinations and rank them based on the same suspiciousness value. So still again Ben recommends us to run these test cases and update the results. So I do that. I have executed these test cases in the past, so I pretty much know the results. For me, in this test case number 3 is result in a failure, rest everything resulted in a past. So I update those. I continue with phase 1. So now I'm in iteration 3. Now there's a new combination which higher suspiciousness value, and again still Ben asked me to run again this further 10 additional test cases, which I have executed, and I have the results with me ready. So I'm updating those results. So now when I execute it, so at this point Ben informs us like the inducing combinations has been identified. What it means is we no longer need to run any additional test cases as if we are doing in the iteration 1, 2 and 3. Now the set of inducing combinations has been identified, which indicates we almost reach end of phase 1. So when we click on this node for inducing combination, we see a list of inducing combinations identified by Ben. Over here it says like, so this is a list of combinations. To start phase 2, we need to select either any one of these combinations and continue to phase 2. For our example, I'm selecting the top ranked combination, which is this, and I'm trying to continue to phase 2. So this is the combination which I have selected. To start phase 2, I need to press on the phase 2 button. Let's see how it works. So I go over here as suggested by Ben, I click on run phase 2. Oh, so phase 2 has been executed. In phase 2, what Ben does is Ben generates a core member test case as well as a derived member. Core member, if you notice in detail, core member should so if you see here, the inducing combinations of pat negate status 1 and sub attention value of 0. So core member will have a test case with these parameters having these same values. I can't expand this. So whereas the derived members will have the alternate values. What I mean as alternate value is, for instance, the inducing combination as pat negate status 1. So if you go to parameters, this variable as 0, 1, 2, 3. So the other possible values apart from 1 will be taken and a derived member will be generated. Similarly for the variable subset sub underscore atn. So based on which core member and derived members are generated. So we need to again execute core member test case as well as the derived member test cases. I've executed them and I have the results ready with me. So I go ahead and update them. Core member, this result in a failure. And also in phase 2, for core member and derived member, we need to upload their execution trace. So what the approach we followed is we use gcov coverage tool to capture the execution trace, and we will be uploading the gcov file. So I have the gcov file with me. Stop research work. I'm sorry, it should be in desktop. It should be in replace program. Okay, so this is the gcov file for the core member. So once you uploaded the gcov, you can view the gcov by clicking on this button. So it opens in a new window over here. The green ones over here indicate these lines have been executed during the for this test case. So let's continue to the rate. This whatever we are seeing was for core member. We'll continue for derive member. So I have the results for derive member. This is a failed test case. The execution trace for this program, for this test case, I'm sorry, is this. Similarly, upload for this too. This will pass and this will fail. So I do the same, pretty much the same. I upload the gcov file for every test case. So uploaded it similar like core member. For derive member also you can see the view execution. When you click on this button, you get the view execution trace. The only difference is it gets open in a separate window. So this is the execution trace for the first test member. We'll go to second, try to open the execution trace. So you can see this is the execution trace of the second test case over here. So this is little idea how the execution how you can view the execution trace. Now since I have uploaded the test results and the execution trace, I can go ahead and click on view this button over here, statement rank. So when I click on this, based on information we provided, the faulty statements are being ranked. So here if you see the ones over here are ranked based on their faulty values. In our example, we have statements which there are three ranks in the whole program. There are a certain number of statements which is rank number 1, other set of statements which is rank number 2 based on their values. So if I filtered 1, I could see all the statements. These are all the statements which are ranked number 1, and this should be the program fault should be somewhere among these lines, within these lines. So this is a basic introduction how to use the tool bin. I hope you like it. Please provide your comments in this comment section. Thank you.